If you want to start, Emma, I'll pass over to you and I'll talk to you soon.
Thank you, Tom. So I'm a data science specialist at Oracle. I work for Oracle for 10 years now, I think. I have experience on analytics, starting from traditional reporting, that was 10 years ago, on Oracle Business Intelligence, for example, then big data, Hadoop technologies, data lake, moving then to newer technologies like cloud for the past 4 years. And for the last 2 years, my focus is on AI and machine learning. My experience spans different industries. The top one, I would say, is telecom, but also retail and healthcare. And I will talk to you today about how we can innovate with AI services and more specific with computer vision. We have a product which is called OCI Vision. So I will try to talk today, as Tom mentioned, we will span from, we will bounce from 4.7 more hands-on demos. And if there is any questions, please use. I think we can use the chat, Tom, to...
Yeah, absolutely. Yeah, the easiest thing to do is post it in chat, or if you're on the Slack channel, you can post it there. I'll watch both.
Okay, so I will, as Tom mentioned, I will try to focus on different industries and highlight use cases we can see with computer vision and our OCI service. This is the safe harbor statement. Now, just to give you a high-level overview, AI and machine learning is an integral part of our Oracle Cloud Infrastructure platform. The platform has all the services you need to migrate, to build, and to run all your IT, from existing enterprise workloads to new cloud-native applications and data platforms as well. It's basically everything from storage to security, integration, data management, everything in here in the lower levels, up to analytics, data science, machine learning part, and the AI services. Now, if we zoom in, our focus for today will be the AI and machine learning part. We have machine learning on different levels, as you can see here. So if you, for example, if you want to build, all these levels actually are dedicated to different types of users. So if you are a data scientist that you like to write code and you want to build your own machine learning models, then you can use OCI Data Science. It provides data scientists with a managed end-to-end environment for building, deploying, and managing the machine learning models. Or you can also use machine learning algorithms. They run inside the autonomous database. So the advantage here is you don't need to move the data. It's all running inside the autonomous database. So it's basically optimized for better performance. And the third level, which is our focus for today, it's the AI services. This is actually a comprehensive set out of the box and pre-trained services and models. So you don't need to write any code. You just import your data and start getting insights. Everything related to the models are all managed by Oracle Cloud Infrastructure. You don't need to worry about anything about building the models from scratch, any model infrastructure maintenance, anything. And we have specific services for speech recognition, for example, for forecasting, as you can see, the computer vision and also anomaly detection, but also the digital assistant. And as I mentioned, today we are going to focus on OCI Vision. Now, this was just an intro for you guys to understand the overall picture and what we are offering in terms of AI ML, and to understand that OCI Vision and the computer vision we propose is just one piece of the puzzle. By the way, if there is interest in all the other any of the other services we offer, perhaps you can leave us a comment, and I'll talk to Tom to see how we can organize a specific session. We also have this OCI Data Labeling, which is actually is not an AI service. It's not AI or ML, but this is something that provides an easy way to label your data in order to custom train the machine learning models for your business. And this is, I put it here on the slide because this is particularly useful to label the images to be used in OCI service, OCI Vision service. So for example, if I'm training a vision model to recognize wells in the oil and gas industry, I have to correctly label the pictures of wells that are used to train my model. So I can use OCI Data Labeling to do so. Now, going into the OCI Vision service, with the rise of digital media, sensors and camera everywhere, analyzing images and video is becoming a key priority, definitely. So customers need to manage this growing amount of images and video data, but it's not just about, it's not actually just about digital asset management. You want to be able to use AI to make sense of this data. So the challenge is that all these models that can recognize, for example, a cat from a cheesecake, don't help you with your specific business, and real world data is often not as the data that you trained on. So at high level, our OCI service is trying to solve the applicable AI scenarios for computer vision. And there are basically two categories of models that we offer for this first release. We have the pre-trained models out of the box to apply computer vision to any of the scenarios that interest you. But we also have capabilities for you to be able to train and use your own custom vision models, again, with all of the underlying work that might be more data science specific, which is abstracted away from you and from the end user. And as mentioned, this is completely integrated with OCI Data Labeling to simplify the data labeling process. And as I mentioned, so you can either use the pre-trained models or train your own model, and it has two main capabilities. The first one is to analyze images for detecting objects and bounding boxes inside an image. And the second capability is around document artificial intelligence. You can use it to understand documents, either scanned PDFs, forms, or even images containing textual information. So we'll be talking about each of them separately. And just three more slides on this one, and then I will go into the application and show you how it actually works. So on the document AI, most of the basic requirements in terms of handling documents is to be able to extract document text out of any of these type of documents. And we have English OCR to handle not only just perfectly scanned documents that you might get from certain types of things like reports, but also documents like prescription pills labels or some third-party applications where there might be handwritten content. And you can handle a variety of data from real life, not only the really nice structured ones. Common applications for this one, or common use cases, because I mentioned I will talk to you about use cases during the entire session. You can use it for reading business reports in PDF forms, receipts and invoices as well, extracting text from insurance or other type of application forms, packages and equipment information, or even mobile uploaded content from workspace. For example, either an employee or customer is trying to take a picture of a document. Now, there is a nice application. It's called Eat and Track for people who want to be aware of what they are eating. So you have the application, you take a screenshot out of the barcode from the product you want to eat, and it will identify the product, and it will tell you the nutritional information, the quantity, and so on. So that's one, let's say, one use case. Then we have the document classification, and this is also a pre-built model that helps us basically assign a document type to any type of document image into some general categories like invoice, receipt, tax form. Yeah. And not sure if it's moving. It also has table extraction. This is more complex type of document scenarios where we have table extraction, and this is used for any document that has table format, either tables with or without borders, with or without headers, and it actually identifies the location of the entire table itself, as well as the individual rows. It also has, and this is the last slide, and I will go into the application. For specific type of documents like receipts, we have a model for key value extraction. So within a receipt, for example, we have fields that are already labeled, like the price, the tax paid, but there are also some information that are not labeled, like the merchant name or the address of the store, for example, or the date, but it also identifies it. And let's go into the application. Let me switch. Okay. So for those of you who are not familiar with the OCI console, we see here on the top corner, you can navigate to any of the Oracle Cloud services, either database, analytics, AI, data lake as well, data integration, but we also see all the other aspects of a cloud infrastructure, like the storage, the networking, the compute, everything. It's integrated in one single platform. To access the OCI Vision, we go to Analytics, and we see here all the AI services. We just click on Vision. I already prepared let's say my screen for it. I think I switched. Sorry. Okay. So we are going through the document AI functionality, and we see here this is where document AI is. So we have a sample image here, a receipt. It's a receipt from Example Cafe. It's just an example, but it's something I want to use to show you the functionality. So we talked that it was basically about the text extraction that we see here under raw text, right? It either extracts as line or as words, depending on your preference. Then the document type that we looked at, it's recognized as receipt. And for the key value extraction, if we look at key value, we talked about some of the predefined fields. You can see some examples here, like the tax, which is 0. And then the certain fields like the merchant name is basically this text merchant name, it's not anywhere in the receipt, but we know that example cafe, it's actually the merchant name, and we see that it's already identified by OCI Vision. So it's mapped to the merchant name. Tom, I'm not sure if you monitor the chat, if there is any questions so far.
I'm watching it. No, we're cool.
Okay, great. Yeah. I want to go further to table extraction, and I have here already uploaded a table-like structure. It's a bit more itemized than the invoice. So basically, it's identifying the boundary of the table itself, as well as you can extract all in tabular format rather than in here, rather than raw text, because there is not very helpful to have it in raw text. There is no relation there. So basically, when you choose the table format or the tabular format, you see the relation between, so for example, the first row here, revenues, and we have quarter 1 for year 12, quarter 2, quarter 3, quarter 4, right? So we see it identifies for first row, for revenues, the numbers by quarter. Of course, this is just about the console experience, but you can just use this programmatically. And if I go to response, just wanted to show you how the JSON object looks like, right? It's just, this is the JSON, and it this is how it looks like that, just considering the table extraction itself. So I'm not sure where there is somewhere the quantity. It's quite difficult to go through this one like this, but you can export it and use it. Let me see. Oops, sorry. Okay. It should be somewhere around here. I can't find it now, but it's in the JSON file. Okay, so basically using this one, it will help you rebuild that table in a structured format after the table extraction. I'll just pop out of the console and go back to my slides. Let me know if you can see it.
Yeah.
Okay, great. So you have seen how Document AI works, and now I want to talk a bit about some of the use cases for Document AI functionality, no matter what the industry is. It's applicable actually to any company and industry because we all have contracts and all kind of documents. So one of the use cases is to be able to do a more enhanced search experience. You might have a lot of image files, unstructured PDF, pictures that you might want to have a better search retrieval over those documents, like the document type, particular text in it, and so on, to understand what is about that document. And for certain type of features like key value extraction, we are doing it for expense reporting scenarios and other types like related, more retail related ones, like how much customers spend in the stores, or for reimbursement in insurance industry, for example. And we also have natural language processing use cases. You can extract text from PDF and organize it as input for NLP, for natural language processing. Now, moving forward to image analysis, we also have a pre-trained model for this, for object detection, in order to be able to identify not only the objects within an image, but also the location in form of bounding boxes. I won't spend too much time on the slides because I want to go into the application again. We also have image classification. This is about classifying what is in an image based on the overall scene. We have pre-trained versions of these models available as in the OCI Vision service, and we can also have custom models. I will discuss about it a bit later. So we have curated pre-trained classes to be able to handle scenarios that might be, let's say, more common for industries like manufacturing, transportation, utilities, retail type of scenarios. We focus on core industries and scenarios that are common to among our customers. So going back to the console, you see the console, okay. We are going to look at the image classification. So we have this image of an, it's a scene on the road. So you can see it classifies pretty standard types of image, actually, let me go to this one first. It's an image of a car, so you can see it classifies really well. It is a car, a bus, another car. It also identifies a person, and with the confidence percentage in it. Right, so it can classify pretty standard type of images like this one. And then moving again to more industry focused, let's say, we have this image with a scene somewhere in this world. If you think of a utility scenario here, where you are trying to monitor anything that might be like detrimental activity around, let's say, your electrical assets, you can see that our pre-trained model is identifying really well things like overhead power line, transmission tower, electrical supply, but also vegetation and the road. This might be a really nice use case. It basically identifies a tree, which might be an overgrowth vegetation that might cause an issue in the future for this specific power line and for this tower. So you can use this to monitor the assets. Or thinking of the telecom industry, you can think of monitoring your network, the optical nodes, and so on. Then more on the retail side, we have a picture with this jeans. Let's see how it analyzes. And you can see that there are details about top categories that have been identified, which is the material, it's denim. We have a pocket. It also identifies the fact that it's a jeans, and also we have the waist, right? So the waist and the pockets of the jeans, also with the confidence percentage for it. So that would be more of a retail, let's say. And now let me select one picture. Okay, so looking at something more interesting. Oh, sorry, I think you see. Okay, Tom, can you confirm you see the?
Yeah, we're back on the
okay.
the console.
Okay. Yeah. Mm-hmm. So looking at something more interesting, you have here one type of bottle that has moisture on it. So it classifies the fact that it's water, it identifies the drops, it identifies the transparent material, liquid bubble, water, and soft drinks. Actually, soft drinks actually is the top, but we also have the other categories. And if we think of use case and of industry, this is something we use. Actually, we are using it now for one of our customers, which is in the industry of recycling the recipients from the water bottles. So basically, they can use this water and fluid classification, which can be related to any time they notice common areas of potential damage, like there is too much moisture on the bottle. So this way they can check whether the triage was done correctly, like no paper in plastic or no moisture in the plastic. And they can monitor the conveyor belt that sorts the waste this way.
So it's kind of like a quality control, Emma, is it?
Yes. For them, it's more than quality control because they actually, yes, it's quality control, if you like to call it in a larger term, because they need to really be sure that there is no water in all the other type of materials they are sorting.
Gotcha.
And if we extend this use case we can extend it actually to also manufacturing, or any type of industry that uses equipments, right? You can check if there is too much moisture on your equipment or anything else that needs to stay dry. And we can find many examples here. Then on the object detection side, we identify things like car, like people, as I mentioned. It also can identify text and extract it. So you can see the plate number, which is here, identified. It identifies the brand, Oracle, the car brand, the car manufacturer, right? It also identifies the taxi name, the taxi brand. So everything that you can see on as a text in the image, everything is extracted. We also have this image with the helmet. And talking about pre-built industry-related cases, again on manufacturing, that it identifies things like the helmet, the person, and the human face. So this might be something you want to monitor for people going into a potentially dangerous worker zone with or without a helmet. So this is for the work safety. And I don't know why it's switching between. So these are type of use cases. There is one more interesting use case that I find interesting on common retail logistics scenarios where you are dealing with packages. We have pre-built labels for box, and again, just looking into what that means in terms of JSON output. I won't show you because I already showed, right, in the response. We get the all the coordinates that are in the image, so we can use that information further. Okay. Switching again.
We're back in the PowerPoint now.
Yes.
Yeah.
I'm not sure how much time. I think we still have plenty of time, right, Tom?
Yeah.
Okay. Use case scenarios related to image analysis. Some of these are for the digital asset management. So you can tag digital media like images, like for better index and retrieval, basically. Then we have this catalog tagging, which is more of a retail use case where you match images in scene with specific goods in a retail catalog. For example, on this picture here, if you can see, it's, let's say, a catalog from a furniture store, furniture and appliances and everything you need for the home. Right, so you see it identifies the cabinetry, stall, the lamp, oven, and so on. So if you think of a catalog in retail, you can actually use this really, really nice. You can use this also for visual anomaly detection. For example, quality control, as you mentioned, Tom, is one of the most common applications for computer vision in manufacturing. And I'm not only thinking about identifying moisture where it doesn't have to be, but since it's a repetitive and error-prone task, manual quality control processes are inefficient when implemented in the large-scale factories. And computer vision quality assurance with much higher speed and accuracy, and definitely save manufacturing facilities time and money. So you can use custom classification to classify products or equipments as standard or defective, and identify which ones are defective and why. Or in the healthcare, we have a lot of use cases, and we actually discussed, if you remember, Tom, I think it was last year, we had a dedicated session in the cloud webinars about computer vision for identifying breast cancer.
Oh, yeah. I remember that. Yeah.
Yeah, from the biopsy images. So in the past, doctors spent hours analyzing medical data to identify diseases and to put a diagnosis. And as the number of patients and the demand increases, speed is something that... So we can help them using this computer vision functionalities to better and accurately analyze things like X-rays, CT scans, MRIs, all the medical stuff, images that they use to identify diseases. Another use case I'm thinking is for crypto. Crypto is one of the newest technologies / industries / groundbreaking. So it's not really new. I think it has like 10 years maybe, but this is increasing, and people start to use automatic software such as there are specific trading softwares. I won't give names because we're not marketing anything for trading in cryptocurrency because it's easy for them. So for example, a cryptocurrency company could use it to identify the cryptography of a transaction. So if the coin is used for this purpose, it can be mined using cryptography. Now, I'm not an expert on crypto, but if there is, I don't know, if there is anyone, I think there was someone from the crypto industry.
Well, we never know, Emma, because they
Yeah, if there are any questions or any thoughts on this, I would be interesting to find. Then moving forward on the scene monitoring, because we also have this one. We saw the example with the transmission tower in the utilities sector, when you want to look at the broader range of assets that you have, places in the utility factory, and understand if there might be anything problematic. Telecom companies as well, as I mentioned, you can use this for scene monitoring of the network equipment, like optical nodes, cables, identify fiber cuts. A fiber cut is probably, an accidental break of an optical fiber, so all the services shut down. That's for the situations where the fiber is not yet placed underground. Also, retail industry benefits from smart store surveillance, through computer vision. So the computer vision enabled cameras can monitor store shelves and each product on the shelves. It can also examine inventory levels and alert for replenishment, for example, but also monitor customer movement in the store to identify hotspots, like, for example, how much a person sits of a specific type of products, and so on. Also, I analyze potential shoplifting, theft, and so on. So that would be another use case. And some other interesting use case, it's a vision used to analyze traffic conditions through on the roads. So they can do traffic management to optimize the traffic flow in the city. Also, maybe they want to monitor people, pedestrians, and so on. But also, if we think about people and crowds, not necessarily on the roads, but maybe also at events, in big stores, and so on. Now, a lot of use cases with the image analysis. Any questions so far, Tom?
No, we're okay. By the way, Emma, you were right. There is. It seems some people think that it's starting in an hour, so I might have to ask you, David, to repeat this starting in about 10 minutes, because it seems there's a bit of a calendar screw up. Some people have it starting, and so you were right. I was wrong about that. No questions. No questions so far.
Okay. Then we have a really interesting use case with OCI Vision and Oracle Analytics Cloud to get more insights at scale. So there will be even a tighter integration between OCI Vision and Oracle Analytics Cloud, but we already have it. And we have here an example about images in a parking lot, where basically you can have many images and you can use vision service to detect the object. So it's powerful to look at just one picture, but when you have multiple pictures, you can look at the aggregated information in all the pictures using this Oracle Analytics Cloud. So basically, you can see how many vehicles there are in total, what type of vehicles, the trend of how many vehicles were in these images, like 4 hours a day, and what type of vehicle there are. You can notice if there are particular spikes, for example, here and here. And you can go to the related images and understand what is happening. So it's really, really helpful. You can notice a larger trend, not only one image, but the total images. And then if we go to custom vision overview, not everything can be followed just in a single pre-trained model. So there are industry-specific things and scenarios, very custom-specific and customer-specific, actually. So we have this custom option available, like you can train a custom object detection or image classification model with your own data set to be able to solve particular use cases. And maybe I'll go to, let me go to the application. So you have here custom models. We usually create, we go to projects section under custom models. The project is the place where you can collect a series of models. So when you create a project, you give, well, I'll just use an already created project. Just go back, just to show you how you can create the project. You give a name and you can give a description, and you can choose the compartment where you want to create the project. Now, I already have a project created, and I will use that one. Then I can go to create model. It's really straightforward. The goal is to be able to actually abstract away the details that require more data science background to create your custom model. So you specify the type of model you want to train, either an image classification or object detection. Then you choose the training data. Either you choose an existing data set, or you can create a new data set. So if you don't have a labeled data set, you can choose to create a new data set. That will be labeled using data labeling service that I've been talking about in the beginning. I will choose an existing one. You can have the data source either in the data labeling service or stored in object storage. Now, I think I need to change the compartment. Okay, let's say I'm using this one, and next, if I click on next, I will just need to type in a model display name, a description which is optional, and then the training duration. Now, there are three types of duration. Let's say the recommended one is taking up to 24 hours. You can have a quick training that will take about an hour. And the custom duration, where you can specify the type of the duration you want. Now, the minimum is half an hour. So at custom duration, you can, if you have larger data sets, you can have more than 24 hours. But the recommended training time is for us is 24 hours. So I want you just give a name and then click on next, and you have this review. I won't save it. So that's everything you have to do, and you have this model created in the list of models. So it's really that simple. And with that, my presentation ends here.